Okay, so today we're going to be talking about congruent triangles. And we've talked about congruency, and that means they have the same shape and size. And so if two polygons are congruent and they have corresponding sides and angles who are congruent, well, then they're going to be congruent. And so it kind of goes both ways on that. And so if you had an identical twin, okay, all your angles and all your measurements should match their measurements. So like your nose doesn't match their foot, but their corresponding sides and lengths and angle of your nose should match theirs, just like corresponding polygons should as well. And so, when we go and name them, one thing that's nice is that if you have it already named, it corresponds with the congruent parts. So let me talk about what I mean for that, okay? And so the first thing is this right here between those two triangles that are shown, you would notice that is like a reflection, okay? So again, my lovely machine is going to make me use my finger to draw it. So I'll do that here. So my font will be precious. So this is a reflection. Here we go, a reflection. Okay, and then for angle A, well, the angle of that triangle that corresponds with angle A would be angle F. Do you see how they're congruent? And then also B corresponds with D. And then C corresponds with angle E. So they would be congruent to each other. And then segment AB would be corresponding with DF. And so they would be congruent. And then also, remember, segments are congruent and the lengths would be equal. So we're talking about the segments. So we have the segment sign over the top. And then BC, excuse me, corresponds with DE. And then we put a segment over the top, and then CA would go with EF. Okay, and then the next thing is the congruency statement should be name the two shapes that are congruent to each other. And so you would say triangle, because that's a shape, and you can write the word triangle. And you have to start at a certain point, and the second shape that you list has to be in a corresponding order. So if you do ABC, okay, sorry, I've got quite a cold. And so if you do triangle ABC, she's congruent. That's a congruency sign. It doesn't look like it, but it is. So A is that small one, and she corresponds with F, and it goes to B. So you're going to go F, D, and then you do E. So you write triangle F, D, E. And the truth is, it's a little tricky to do sometimes, but when we're going to do some proofs in this chapter, and it's important to be able to say, what have I proven to be congruent? And then also, if someone's reading that and they're like, oh, look at this. And given that these two parallelograms are going to be congruent, well, if you look at this order of this parallelogram and compare it, to the parallelogram over here, the order it is signifies not only the corresponding segments, but also the corresponding angles. So in this one, the first two segments would be QR. So you do QR is going to be congruent to OM. And then the second two letters would be RS. So RS is congruent to the second two letters here, which would be MV. And then the third ones would be ST. These last ones here go with VW. I'm out of space. And so the last ones would be the outer ones. So QT, so QT, so let's go over here. QT corresponds with OW. Okay, so there's a four-sided figure. Each four of the sides has a corresponding one on the congruent shape. That means they're going to be the same shape and size. And then that also means that the corresponding angles will match too. So, excuse me, if angle Q is say like 30 degrees, so will angle O be. So angle Q is congruent to angle O. So the first two letters. And then you would say angle R, which is the second angle, is going to be congruent to angle M. And then you could say S versus V. And I'm out of space. So you can write yourself T goes with W. Okay, and so what we're going to do practically with that would be problems like 3, 4, and 5. Okay, if I tell you that these two triangles are going to be congruent. That means their corresponding sides will be equal in measure. Okay, so if I see GH, okay, who corresponds with GH would be the first two letters of the next one. That would be LK. So that means that 2x minus 2 is equal to the length of 6. Because if these two shapes are congruent, you know, they talk about one as 2x minus 6 in code because they think they're all precious, but they aren't. But really, we know that length is actually 6. And so, okay, so if you solve that equation, then you're going to add 2 to both sides. You get 2x equals 8, and then x is equal to 4. Okay, so that's the solve for 4. And if you notice, if you plug that into this side right here, 2 times 4 is 8 minus 2 would give you the length of 6. So yeah, those two sides will be congruent to each other. They just talk about the one in terms of x a little silly. And then what would be the measure of angle J? Well, angle J is this one over here. How would you find it? Well, let's think about it. You know, if these two triangles are congruent, well, if we find the measure of this angle here, it's a right triangle. And so to find the measure of the other acute angle, you would do 90 degrees minus 53, and you get the measure to be 37 degrees. So because these two triangles are congruent, this will also be 37 degrees as well. So kind of helpful. Okay, so I'm out of breath because I've got quite a cold. Let's check out number 4. Okay. Pardon me. So for this one here, we've got, you can see that LM corresponds or is congruent to QR. And so LM and QR are equal in length. So you can do 2x plus 11, and you can set that equal to 3x minus 9. You saw that you get x is equal to 20. Okay, so x is 20. And then the other thing is angle M, you know, if you look at that, angle M is the angle in the middle. She corresponds with R. So M goes with R. Okay, so we can set those equal to each other as well. And so if you do y plus 10 and set that equal to 2y minus 40, if we solve that for y, you're going to get y is equal to 50. Okay, so a little bit of messy handwriting, but if you set these two angles equal to each other, y plus 10 equals 2y minus 40, and solve it algebraically, you're going to get y is 50. The next one, I really should zoom in because we're going to need some more space. This is like we reviewed on Delta Math recently. And it's kind of cute, but also kind of a pain. If you look at these, it says, can you find the measure of MN? So we're going to have to find x and y and add them together to get that answer. So I think the big thing is who corresponds with whom. And if you read the incongruent statement on the left, LM actually corresponds with QR. So we can write an equation about that statement. Okay, so we can write 2x minus 4y is equal to 10. Okay, notice it has 2 letters in it. You're like, this is not ideal. Well, we can solve a system of equations. This is a review from Algebra 1. The other thing that's true is going to be ln corresponds with this one right here. Okay, and so if you write that down, you're going to get 11 equals 4x plus y. So I'm going to do 4x plus y equals 11. Okay, you can write it either way. You see the symmetric property. And so you can do substitution, you can do elimination, you could graph both lines. I want to do elimination, and so what I'm going to do is eliminate the x's by multiplying the first row by -2. So if I multiply the top row by -2, so the x's will be the same number but opposite, I'm going to get -4x plus 8y, and then that equals -20. And so if I add the two equations together, I get 9y is equal to -9, so y is equal to -1. Okay. Feels like it's alarming when a variable for shape is negative, but we can look and see, you know, do we throw it away? Is it extraneous or is it actually a value that we can use? Okay, and then the next thing is we can use one of those two original equations to say, okay, let's find the value of x. Okay, and so I'm going to look at the second equation, okay, which says 4x plus y is equal to 11. And if we know that y is -1, you're going to do 4x minus 1 is equal to 11. Solving it, you add 1 to both sides. 4x equals 12. So x is equal to 3. Okay, so x is 3 and y is -1. So if we want to find the length of this side right here, okay, we're going to take x and y and we're going to plus them together. So if we do 3 plus, and we're going to do -1, that length of mn is going to be 2 units. Okay. So the length can't be negative. And if you tried to look and see, does this mean that any of the other sides would be negative? They shouldn't be. I could have made a mistake when I wrote this, but it should be okay. So set corresponding congruent sides equal to each other or angles as appropriate. Okay, if you've got congruent triangles or polygons, you can set their corresponding parts are equal to each other, their measures. So some things that will be helpful. Third angle theorem. Okay, if two of the angles in two triangles are congruent, the third one has to match as well because they both had to be 180. Another one would be midpoint theorem. If C is a midpoint of AB, the result is AC is congruent to CB by the midpoint theorem. Okay, so that's what you'd put. Definition of an angle bisector. If BD bisects this angle, then the result is angle CBD. Make sure you put an angle in front of it. I did that for you. Is also going to be congruent to ABD. It cuts it into two congruent angles. Make sure you put the angle thing, angle symbol in front of it, or write the word angle. Okay, bisect means it chops something in half, whether it's an angle or segment. The reason why it does that is the definition of angle bisector. Definition of a segment bisector is if you've got segments that get bisected, well, it breaks those segments into two congruent pieces. Okay, so those two match, and then these two match. We don't know that all four match unless they tell us about the original congruence of both segments, but we do know each one gets broken in half. So the length of RS is going to be, okay, so segment RS is congruent to ST. Okay. Yes, that means the lengths will be equal as well. We could go a step further if we wanted to. And then also QS is congruent to, you can almost write that, it's going to be congruent to SW. Okay. All right, the next part of the notes would be on the back side. Let's go to those guys. So the first thing is, okay, if I tell you that TR bisects angle QRS, well, then we know these two angles will be congruent. So you can say angle QRT is congruent to angle SRT by definition of angle bisector. If TR bisects segment QS, well, that means that QT is going to be congruent to TS. If they bisect each other, we just did this. We could say AC is congruent to CE, and then we could say that DC is congruent to CB. I'll let you guys write that as you want. And then the last one is the same thing. Which angle gets bisected? Just be careful. When I gave this last year, kids were like, I don't know what angle is getting chopped. Well, read the one. DCB is over here. Okay, DCB is here. So that means that this one will match this one over here. And so you could say BCA is congruent to DCA as well. Okay, so I'll save time and let you guys do that your own self. Okay, so for the proofs, today we're going to be talking about how can you show that two triangles are congruent. And the way that we do that is definition of congruent triangles, which is if every angle corresponds with a congruent angle of the second shape, then every side is congruent to a corresponding side of another shape, well, then the two shapes, the two polygons have to be congruent. Okay, so we got to show every side and every angle has a congruent part on its twin, okay, on its congruent part. So they give us some stuff that says P and M are right angles. Okay. So again, out of breath, my lungs are not very happy with me. Okay, so those are going to be right angles, and P and M are congruent. And it says right angles congruence theorem, okay? If you look back at your old sheets, you should be able to see that on there. So basically, if two angles are right, then you know that they have to match each other, okay? Because right angles are congruent to each other. Okay, QN and PM bisect each other. And then, so that's given. So we're going to write given, okay? The next one says that their two parts are going to be congruent. So if the two segments bisect each other, then that segment matches this one. And this one is going to be congruent to this one. Why? Definition of segment bisector. Okay, and then there's something else that's given. Oh, QP and NM are congruent. So QP is congruent to NM. So we should mark it. So these match up with this one over here. Okay, and that's by given. Okay, so we've got all three sides matching each other. We have one angle matching. We got to do the other two. Okay, and so we can do QRP. Okay, those are vertical angles. Why? Definition of vertical angles. Okay, and then that means that angle PRQ is congruent to angle MRN, okay, by vertical angle theorem. And then Q and N are congruent by the third angle theorem. If we know two angles match, which we do know, these vertical angles match each other and the right angles match each other, well, then the third ones of each triangle have to be the same by the third angles theorem. Okay, that says theorem. Sorry, it's pretty bad. And then the last one is triangle PQR will be congruent to triangle M and R. The order matters, but they gave it to us, so we don't even have to think about it. So M and R, because the corresponding angles and sides should be congruent to each other in the right order by the definition of congruent polygons. If all the corresponding sides are congruent, if all the corresponding angles are congruent, then the two shapes have to be congruent to each other. Okay, so definition of congruent polygons. Okay. Okay, the next one is going to be similar. We've got to prove that these two triangles are congruent. How do we prove it? Show that all the angles correspondingly match with the other one. Show that all the sides correspondingly match with the other one too. Okay, here we go. I'm going to try and see if my pen will work for once, because that might make the font a little bit better. Let's see, N and R are congruent. That is a given. Okay, nope, it's not going to work. Okay, so let's write given. Okay, MP bisects NMR, that's given as well. And as a result, okay, so we know N matches R. Always label your diagram. MP bisects NMR. So you know, pardon me, that those two angles will be congruent. So you go angle NMP is going to be congruent to angle RMP. RMPY, definition of angle bisector. Okay, so we've got two of the three angles. So guess what? By the third angles theorem, well, then the other two angles have to match each other as well. Okay, so if those two match, the third ones have to as well. And so you would say angle NPM has got to be congruent to angle RPM by the third angles theorem. So we've got all three angles matching. Okay, so this one matches this one right here. And then P is the midpoint of NR. So that means these two segments are congruent. So that means that it's given. So that means NP is going to be congruent to PR by the midpoint theorem. Okay, and then we got something else that's given. MN and MR are congruent. MN is congruent to MR. And we're trying to show all the sides match. So this one matches this one down here. And then the last one is going to be MP matches itself. Why? Do you see that MP is a member of both triangles, but it also is the same length, either one it's in? It's called the reflexive property of congruence, and then therefore they are congruent to each other by definition of congruent polygons. We have some shortcuts that we're going to learn tomorrow or Monday, and so because it's kind of tedious to have to show that all the sides and all the angles are matching, because you're like, I kind of get the gist if enough things match, but this is the most basic, is to show that every corresponding angle matches the corresponding angle in the other shape, and then also the corresponding size. Well, thank you for putting up with my lovely cold. I hope you have a great day.